Hello and welcome back to the lecture. In the previous lecture, we have created the schematic symbol for this MOV or metal oxide resistor, and in this lecture, we are going to create the PCB footprint for this component. So for that, go to your project, that is mov.lib package or integrated library package. Right click here and click add new to the project. And this time we have to select PCB library. In the previous video, when we were creating this symbol, we have chosen this one, that is schematic library, but this time we will choose PCB library like this, and a file will be created here, pcblib1.pcblib. So this one is the extension for this file, this type of file, pcblib or PCB library, and this one is schlib or schematic library. Now save this file, choose a proper name like this, MOV. Don't type the extension, it will automatically assign the extension to this file. Click save and save the project too by clicking save all. So this is the user interface to create PCB footprints. We have these black lines, these are grid, snap grid. So things snap to these grids. And in while designing the PCB footprints, it is important to take care about the unit. So while PCB designing or while footprint designing, we have option for two different unit, and one is the imperial unit like inches and mils. On the other hand, we also have option for newer metric unit which has millimeters or mm. So you can switch between the unit using the Q key on your keyboard like this. Just keep your eye here. By default it is mil, that is imperial unit. So this mil is the 1,000th of an inch. Right now my grids are 5 mil, and when I press Q key on my keyboard, it will change to metric unit. Now the same has been converted to mm or millimeters. So in this way we can, this is imperial, Q again, and metric. So this way we use the Q key to switch between imperial and metric unit under Altium Designer. And navigation in this view is also similar what we have discussed in the previous video, that is while making the schematic sheets, while drawing the schematics. So simply rotating the mouse wheel will scroll up and down like this. This is the origin in the center, and to scroll horizontally, this was vertical scroll. So to scroll horizontally, we can press the shift key on our keyboard and then move the mouse wheel, and now this time it will pan or scroll horizontally like this. And to zoom in and zoom out, we can hold the control key in place of the shift key, and this will zoom in and zoom out of the document like this. And in the same way the schematic editor had the place menu, this one is also having the place menu, but this time it is containing different items. So we'll begin by drawing a simple two-leaded component, this one, this MOV, and this is a simple through hole component, not an SMD or surface mount component. So what we have to do, first we need to go through this data sheet, the data sheet of the part that we are drawing the footprint for. First download the exact data sheet, and it will contain dimensions like this. So this diagram here, it is showing all the dimensions, but it is showing in a general form. It is not having a numerical value for this V, rather than it is having a placeholder or variable for this, like this diameter of this pin or leg or lead. And so this one has been given a symbol of small e. So this is the pitch. So generally the distance between the two pins of a component is called a pitch, and generally it is represented by this symbol, that is small e. So we have various different variants of this MOV, and each different variants had different value for this E, B, everything. So we are drawing for this one, that means S20K30, and this one is having a pitch of 10 millimeters. So you have to see the unit here is millimeters. The pitch is 10 millimeters. So better we should design our component in millimeter range. So this is already set to millimeter units, no problems. And then what we have to find, we have to find the diameter, this diameter of this leg. So this is small d. So in the table we have small d where it is in the last column, and it's in millimeter too. So where we have this one, so this one is having a diameter of 1 mm. Okay, great. So now we have to do what we have to do. We have to place a pad. So place pad. Where is my pad? Here is pad, like this. Now in the same way we were using in the schematic editor, we can use the tab key to edit the properties of this pad, and here we can see all the preview. So what we have to do, hole information. So what is the diameter of the hole? So the hole is 1 mm. This is matching my data sheet. Here we have a 1 mm. The lead is 1 mm, so we can increase the size a bit, okay, so that it fits easily. We can choose say 1.1 mm. How about this 1.1 mm? And what should be the size of the hole, and what should be the shape of the hole? Generally the holes are round. In the advanced lecture we will see about rectangle and slot holes, and make sure this one is selected, that is plated. So what is plating? This plating is when you create a multi-layer or a double layer PCB, then the pads on the top layer and on the bottom layer, they are connected by using some metallic filling inside this hole, that is called plating, so that the top copper layer and the bottom copper layer are electrically connected. So make sure it is selected. And designator, choose one here, because we are creating a 2-pin component, so we are having only 2 pin. The first one is called 1 and the second one is called 2. Layer, multi-layer, net, no net, load, not important. Now the most important thing is here, the shape of the copper pad. So right now it is what it is selected, shape is rectangular, so you can change this to, see the preview here, round. So rounds are something like this and rectangulars are something like this. So I think for this component rectangular is better, so I'll go with rectangular, and we will make this 2 mm by 2 mm. So this square is 2 mm wide and 2 mm height, like this. Hole is 1 mm and it is twice the size of the hole, so that we can easily solder the pad. These are default values are good, that is paste mask expansion from expansion rule from values. So what is the meaning of this, we will explore in the advanced lectures. Right now it is not important, only two things: hole information, plating, and the shape and size of the pad is important here. Great, now we are all ready to click OK. Now place this pad. Now let us change the grid a bit. So this grid is very fine. Place G on the keyboard, select, I think 0.25 mm is good, and we can place a pad here at the origin. Great. Now you can find that the number or the designator number has already automatically increased to 2 from 1. This is a great feature that makes placing multiple pins very easy and less time consuming, very fast. Now where to put this second one? So we have seen from the data sheet of the component that these have 10 mm distance between them. So you can keep an eye here. So dx and dy. So this dx is the displacement in the x direction and y is the displacement in the y direction. So how much displacement we need? We need 10 mm. So keep on moving until we get a 10 mm gap, like this. This is a very big component. This is exceptional components. Generally the capacitor and resistor are much smaller, like this. Now we have successfully placed this at a gap of 10 mm as mentioned by the data sheet. And now let us verify that the gap or the pitch between these two pins is exactly 10 mm. So we can go to this menu, that is reports menu, and from there select measure distance. And this command can also be activated using shift plus M. You can see, sorry, control plus M. And this command can also be activated using control plus M keyboard shortcut. and go to the center of this pin, that is first pin, and then drag from there to there, that is center of pin 2, and let us see how much is the distance. So the distance is 10 millimeters exactly. Great. And you will also see a marker like this getting drawn here. To get rid of this, simply press shift plus C or clear. It will remove it. And now the next step. What is the next step? The next step is the drawing of silk screen layer. So at the bottom we can see several tabs or the buttons to activate different layers. So this is the top overlay. So this one is the silk screen layer, and in this layer we draw the outline of the component so that it is easier for the soldering operator to insert the component at proper place. And for that, what we need to do, we need some extra information from the data sheet. But before that, first draw a simple outline. Just go to the place menu, select line, and draw something like this. And here you have to make sure that this line is drawn in yellow color. Why yellow color? Because you can see the color of this top overlay layer, it is yellow. So anything that is placed in this layer, that is top overlay or the silk screen layer, must be yellow. Place wire. So like this. So by mistake, say if you have selected top layer, so in that case if you place a line, it will be shown in this red color. So this is wrong, this red color is wrong, this yellow color is right. And if you draw like this, it will be get drawn in the copper layer, and it will be etched in the copper, conductive copper layer. But what we need is a only white ink based printing for documentation. Now let us get rid of this that I have just created for demonstration. And now we have to draw the silk screen or the outline layer. For that we have to consult the data sheet. And here is my data sheet, and what I need to find out from this, I need to find out the diameter of this disc. So the diameter of the disc is B, this symbol B, small b I think. So let us find B max here for our selected part, this one, and it is 21.5. So this entire diameter is 21.5. We have to draw a silk screen accordingly. So let us consider this 21.5. Let us consider this 22. Okay, with some margin, we have kept some margin here to make it 22. So the diameter of this disc is 21.5, which we have considered 22 with some margin. So from this 22, first we need to reduce this thing, that is the gap between this thing. So let us open our calculator, and we have 22 total diameter minus 10 that we have already taken the gap between these two pins. So we are left with how much? 12 millimeters. So now we need to divide this 12 into two part, that is divide by 2. So we get 6. So we need to extend this 6 millimeter from each of this pin. So let us measure the distance, report measure distance, and we have to measure a distance of 6 millimeter here. 6 dx is 6 millimeter distance, 6 millimeter labeling. Great. Same we have to do here also, from pin to 6 millimeter on the other side. Great, we have 6 millimeter. So we have to draw outline till this point. So let us extend this to here like this and like this, and let us select this one and control C, and we have to mark the origin. Let us click here. After that it will be copied. Now paste like this, so that we have the two side of this disc. Great. So now this complete from here to here, it is the exact size. Match it, it is bit bigger, so match it till this dimension. This is good. Now one thing we have to do, we have to get the width of this thing, the box, the outline, how much width we need. Again the data sheet will help. So this thing we need small s. So this is the width of the or thickness of this disk. Capital S is in this column. For this one it is 4.9. So 5 millimeters we can take. So report measure distance. Let us check how much is the distance presently. It is 5 millimeter by luck. So if it is not, in your case, if it is not 5 millimeter, then make it 5 millimeter. One more thing we need to do, that these two pins are not in a straight line. Consult the data sheet. We can see that there is some vertical gap between these two pins also, and this is designated by this small a. So how much is this small a? Small a for 20k 30, small a, this one is 2 millimeters. So we have to keep a gap of 2 millimeters here. So we can move one of the pins. We can do two things. Let us move this 1 millimeters upward. So as we know that our this grid is this thing 0.25 millimeter. So to move 1 millimeter upwards, what we need to do, we need to move 4 steps. Okay, and this can be done using like this. Select this one and press the control key on your keyboard and then press the up key. So 1 unit, 2 unit, 3 unit, 4 units, like this. So it is going here, and let us move this downwards 4 unit. 1 2 3 4. Now the vertical gap between these two pins, if we check again using report measure distance from center of this pin to center of this pin, and we have to pay attention here, that is the Y distance. Now the Y distance is 2 millimeters, which is matching this one, 2 millimeters exactly. So this is the size of the disk. So we can see that this silk screen is touching these pads, so we can move them bit upper like this. 0.25 millimeters, 0.25 millimeters, not bad, great. Now let us get rid of all these markers, but we will draw a curvy thing here like this, because this is a disk. We can also draw it like this, and the shortcut for placing a line is P followed by L. So P followed by L, it will place a line like this. You can do like this. So again I have made this in a wrong layer. First choose the layer here, top overlay, and then place line. Now it is correct. So we can do like this, or on the other hand we can make it bit curvy. So for that what we need to do, go to place, then go to arc, edge based arc, and now click here. If it is going opposite like this, press space, it will turn its direction, and click on the center like this, and then again it's wrong orientation, place space and connect here. So we have a nice curvy thing here, not a rectangle, but this is increasing the size. So what we need to do, we need to match this thing to this place. So what we need to do, we need to reduce this like this, we need to reduce it, and then select these two. To select multiple item, you can draw marquee like this, or you can select this one and press and hold the shift key for multiple selection, and then click the next object, and then use the control plus arrow key to move it like this, so that it touches. Now it is better. We still have some gaps here. Now it is best. Okay, great. And we can replicate this thing, select this thing, both the thing, and then select control plus C, copy, and then select the origin point, and then click control plus V, standard keyboard shortcut, to paste this thing. Now to rotate, press space twice to rotate it, and get rid of this. Select, hit the delete key on keyboard, place it like this. Okay, again reduce the size like this, something like this, and select both of these. Use control plus arrow key to move this like this. Great, I think. Still we have some gap here. So we have small gap here also. I think let us move it one more units. Much better. Great. Now we have a great outline for these components that will be printed in the silk screen layer of the PCB. Now let us get rid of all this dimension by pressing Shift plus C. Clear. And one more thing, we have to pay attention to the thickness or width of these lines. So currently it is 0.2.54 millimeter. So this corresponds to 10 mil. If you change the unit by pressing Q key on your keyboard and then double click on any of the line, this properties of this line will open up in this dialog and it will show you 10 mils. Okay, so this 10 mils is the default. If it is something else, you should change it to 10 because this 10 mil prints good on PCB. I have tested it practically. If you need thinner line, you can reduce to 8 mils, or if you need thicker lines, you can change to 12 or 14 also. But less than 8 mil, the lines are too thin to be seen on PCB. That you have to take care. And finally, we need a 3D body for this footprint. To get the 3D models, we will use this site, that is 3D Content Central. So here is the site 3dcontentcentral.com, and you need to register an account here before you can download files. Here is the site 3D Content Central. Here you can get various electronic parts 3D models. So we'll search for 20 mm MOV, something like this. You need to be creative in order to find the specific component here. And here we have a MOV. This one is 20 millimeters, looking good. And here they show the 3D preview also directly on the web page. The drawing is loading. The turn, you can rotate it here to see the preview from various angles. Use your mouse to rotate this, and when we are satisfied, we can download this. And what format we need? So we need step format. Here is step. Version is okay, AP214 zipped. Download. It will download you the package. Click on this link and it will download here. Extract the files. It will be a .step step file. Download it in a folder where you keep all the 3D models, and then go to Altium. Now to import a 3D model in Altium, we have to go to the place menu again and then select 3D body. And here we have the dialog and 3D model type. Here we need to choose this one, that is a generic 3D model, not extruded, not cylinder, not sphere. Then we have the option load from file, and from there select our 3D model of MOV step file. So it is supporting, you can see it is supporting step file. Click open like this and just click OK, and it will come like this on your footprint. But as you can see, the orientation is not right, but just place it somewhere by clicking, and it's again trying to load a new model, but this time just select cancel. And this pink thing is our 3D model drawn in a 2D method. Now we need to switch to 3D view in order to view this model. So for that, click anywhere inside this gray area and just hit 3 key on your keyboard, and it will turn to a 3D visualization. But we can see that the orientation of this model is not correct. But let us first try to learn how to navigate in 3D view. For rotation, you just click shift key on your keyboard and this thing will appear on your screen. And then just this one is the vertical direction and this one is the horizontal direction. So any one of the directions selected like this, just press the right button on your mouse and move your mouse and it will rotate in that direction, and in the same way in this direction also. This will activate rotation, so it will rotate it. Not so much useful, better to do like this. But now we need to rotate this model to correct orientation, so just click on it to select it, or double click it to open this dialog, and then rotate. Here we can specify the rotation. Rotation in x direction, y direction, z direction. Just change this to 90 degree and let us see what happens. Now it is in correct orientation. See, now select this model and again press the control key and up down key to place it in the proper place like this. But here I have done a little mistake. You can see we are not able to match the pins with the pad. This is a common error in PCB designing or footprint designing. So what is the problem here? So this problem is due to the fact that this view is bottom view. Clearly written here that this is the bottom view. But the view that we get in Altium, this is top view. This is very important fact to remember, that always the PCB design software, most of the PCB design software including Altium, always by default show the top view. That means when viewed from the top side. So this is the problem. So what mistake I have done, that they are showing this view, that is bottom view. So they are showing it like this from the bottom side, like this. So this is the bottom view. We can see that this top pin is at more height, while this bottom pin, that is this pin, is at less height. But what I have done, that when we are viewing the PCB view, we are viewing it like this in Altium, like this. You can see that now this pin becomes more height and this pin becomes the lower pin at less height. And there is no use even if I rotate this component like this, still this left pin is at more height. So now how to rectify this mistake? For that we need to move this pin 1 upside while this pin 2 downwards like this. But first we have to reset the positions because we have already moved them up and down. So now I'm showing you alternate method to move these pins, and this one is much more accurate. So you just double click on this pin and watch for the x and y location. But first let us change the unit to metric. Great. So now we can see that this pin is at -1 location, pin 1, while pin 2 is at +1 location. Okay, so initially they were both at 0 0. So if we change, we can directly rectify the mistake very quickly by making this -1. So this will come parallel to pin 1. Now time to move this pin 1 upwards. For that, just remove the minus sign and make this from -1 to +1 millimeter. Move it from -1 millimeter to +1 millimeter like this. Now their locations have been swapped. This pin becomes the top, means it moves towards this direction and this to this direction. Now we can easily match the pins. Now let us switch to the 3D view by pressing 3 key on the keyboard, and great, see, and just rotate it to view the bottom side and select this 3D component, move it. Great, see the pin matching perfect. Okay, now the component is fitting perfectly in its footprint. And this is the top view. Now our PCB footprint is completely finished. Now it's time to link this footprint to our schematic symbol that we have created in the previous video, which is available here, mov.schlib or schematic library. And how to link this to the PCB footprint? You have to use this button, that is add footprint. and you can just browse and select this component. You can see the name is not correct, so better first change the name. So go to your this one schematic library, change the name from here to PCB components to something descriptive like MOV 20 mm. Good, name changed. Go to your schematic symbol and add footprint, browse MOV 20 mm. It will show you a preview here, both 2D and 3D. You can use the same navigation method here also to navigate and view this component. Click OK, and will link your the schematic symbol to this footprint, which is also having the 3D model. Just click OK and you can see the model attached here. Save everything, and now it's time to compile this project. Okay, how to compile the project? Go to the project menu and select compile integrated library, and if everything is okay, you will not get any error, and it will be linked, everything will be linked. So here you can see the linkage. We have this MOV part number, that is S20K30. We have the symbol, schematic symbol, we have the footprint, we have the 3D model, the 2D footprint, everything in one place. And when you compile an integrated library project, it automatically install that library in your standard library list. So just to check it and verify it, just open any schematic document or SCH doc like this, and here in the schematic document you can see your libraries here. So the newly created library is called MOV. It is at the end of the list and it is having a single component, but previously it was only having this schematic symbol. Now it is having this models also, both footprint and 3D models, everything is there. So we can now just drag it from here to here, and it will become available in our schematic. We can make connections and all the footprints and models will also be available along with this. And now this integrated library is all ready to be shared. It can be shared with your colleagues or anyone using the internet. So let us see how to do that. For that, just open your file system where you have created this library, and here is my project folder in my file system, projects Altium live MOV, and it has this folder that is project output for MOV. So this is the name of your project, and this contains all the output files, the files that are generated after the compilation of this input data. And here you can see an interesting file. This is mov.int library, or an integrated library. This is the compiled library ready to be distributed. So you can see that in our source file we have 2 or 3 different things. So first one is the project file, then we have the footprints and 3D models, and this one is containing the schematic symbol. But when we compile them, it becomes a single file. It has everything. It has a schematic symbol, it has a PCB footprint, and also the 3D model. So this file is ready to be distributed. Okay, you can place it into your web server and provide a link to download if it is a free and open source one. Otherwise, you can attach this file in your email or any cloud storage service, and distribute it among your colleagues. So hope you have enjoyed this lecture. Thanks for watching. See you in the next video.